different variables, basically, and that's going to allow us to separate the variables. So what they look like is we have dy dx equals, you're going to have some function that's defined with the variable y and some function that's with the variable x. And so we are able to separate them then, when the goal is we would want to put the dx on this side, so we'd multiply by dx, which would give us g of x dx. And over here, we'd want to put the f of y over here, which would leave us with 1 divided by f of y dy. What we do next then is we find the antiderivative of both sides. Okay, so we did this a little bit when we were dealing with slope fields, because this is also called a particular or an exact solution. Because when you integrate both sides, then you end up having a c, and then sometimes I give you information which allows you to find the c, and so on. What ends up happening a lot of the times is we get some things with natural log, because isn't the antiderivative of 1 over y natural log y? And so then we end up getting, how do you undo a natural log? Exponential equations, right? Okay. So first of all, I'm going to just show you how this works in general, and then I'm going to show you why it's related to exponential equations. So let's say for my example, I had dy dx equals xy squared, and it contains the point y equals 1 when x equals 1. So then, this is x squared, y squared, agreed. So I'm going to leave the x squared over here. If I separate the variables, I have x squared dx. And over here, wouldn't I have 1 over y squared dy? You guys following okay? So if this was a 1 over y, I'd leave it because the antiderivative is natural log of y. Because it's y squared, I'm going to rewrite it as y to the negative second. All right, so next step. If I wanted to find an actual solution to this, a y equals equation, I am going to next take the antiderivative. And keeping in mind, on these, when I take the antiderivative, don't I have to write a plus c and a plus c? What I do then is, because technically I'd move this c to the other side, I don't end up putting a plus c and a plus c, I just end up putting it over here. Because when you subtract a constant from another constant, you're still going to get a constant. What's the antiderivative of y to the negative second? Add the 1 back on. Negative y, or negative 1y to the negative 1. How about this? And we have a plus c and a plus c, but I'm going to just put it over here. Okay, next. I'm going to simplify this. Wouldn't you agree this is negative 1 over y equals 1/3 x cubed plus c? Let's go ahead before I get too complicated, because really when you're solving an equation, remember in Algebra 1 how I'd say solve for y? We're going to solve for y. But before we do that, let's find c. You're going to be given some information in the problem that allow you to find c. It says when y is 1, x is 1. And so what I'm going to do is I'm going to put those values in. So I put 1 in for y, that's negative 1 over 1, or negative 1. If I put 1 in for x and cube it, wouldn't that give me 3 plus c? Subtract 1/3. Or I can write it as negative 4/3. Okay, so now let's go back to where I initially put C in the problem. Right here. And let's finish off our equation. I have negative 1 over y equals 1/3 x cubed minus 4/3 guys, couldn't I write this as x cubed minus 4 over 3 if I wanted to? Okay. So when you're solving for y's, the couple things. First of all, if you want to get rid of the y to the negative 1 part, you can multiply both sides by a negative 1. Okay, and also if I wanted to figure out what y is, I can just flip both sides, take the reciprocal of both sides. Okay. So first of all, I'm going to multiply both sides by negative 1. I get 1 over y equals, you can choose to do the bottom or the top when you multiply by negative 1. You just don't want to do both. I'll do the top. Are you still hanging with me, guys? Then let's take the reciprocal of both sides. What's the reciprocal of 1 over y? Y. What's the reciprocal of this? 3 over negative x cubed plus 4, or you could write that as 4 minus x cubed, your choice. Okay.